So when you look out at the stars at night, it's amazing what you can see. It's beautiful. But what's more amazing is what you can't see. Because what we know now is that around every star, or almost every star, there's a planet, or probably a few. So what this picture isn't showing you are all the planets that we know about out there in space. But when we think about planets, we tend to think of faraway things that are very different from our own. But here we are on a planet. And there are so many things that are amazing about Earth that we're searching far and wide to find things that are like that. And when we're searching, we're finding amazing things. But I want to tell you about an amazing thing here on Earth. And that is that every minute, 400 pounds of hydrogen and almost 7 pounds of helium escape from Earth into space. And this is gas that is going off and never coming back. So hydrogen, helium, and many other things make up what's known as the Earth's atmosphere. The atmosphere is just these gases that form a thin blue line that's seen here from the International Space Station, a photograph that some astronauts took. And this tenuous veneer around our planet is what allows life to flourish. It protects our planet from too many impacts from meteorites and the like. And it's such an amazing phenomenon that the fact that it's disappearing should frighten you at least a little bit. So this process is what's something that I study, and it's called atmospheric escape. So atmospheric escape is not specific to planet Earth. It's part of what it means to be a planet, if you ask me, because planets, not just here on Earth, but throughout the universe, can undergo atmospheric escape. And the way it happens actually tells us about planets themselves. Because when you think about the solar system, you might think about this picture here. And you would say, well, there are 8 planets, maybe 9. So for those of you who are stressed by this picture, I will add somebody for you. Courtesy of New Horizons, we're including Pluto. And the thing here is, for the purposes of this talk and atmospheric escape, Pluto is a planet in my mind. In the same way that planets around other stars that we can't see are also planets. So fundamental characteristics of planets include the fact that they're bodies that are bound together by gravity. So it's a lot of material just stuck together with this attractive force. And these bodies are so big and have so much gravity, that's why they're round. So when you look at all of these, including Pluto, they're round. So you can see that gravity is really at play here. But another fundamental characteristic about planets is what you don't see here, and that's the star, the sun, what all of the planets in the solar system are orbiting around. And that's fundamentally driving atmospheric escape. The reason that fundamentally stars drive atmospheric escape from planets is because stars offer planets particles and light and heat that can cause the atmospheres to go away. So if you think of a hot air balloon, or you look at this picture of lanterns in Thailand at a festival, you see that hot air can propel gases upward. And if you have enough energy in heating, which our sun does, that gas, which is so light and only bound by gravity, it can escape into space. And so this is what's actually causing atmospheric escape here on Earth, and also on other planets, that interplay between heating from the star and overcoming the force of gravity on the planet. So I've told you that it happens at the rate of 400 pounds a minute for hydrogen and almost 7 pounds for helium. But what does that look like? Well, even in the 80s, we took pictures of the Earth in the ultraviolet using NASA's Dynamic Explorer spacecraft. So these 2 images of the Earth show you what that glow of escaping hydrogen looks like, shown in red. And you can also see other features like oxygen and nitrogen in that white glimmer in a circle showing you the auroras, and also some wisps around the tropics. So these are pictures that conclusively show us that our atmosphere isn't just tightly bound to us here on Earth, but it's actually reaching out far into space, and at an alarming rate, I might add. But the Earth is not alone in undergoing atmospheric escape. Mars, our nearest neighbor, is much smaller than Earth, so it has much less gravity with which to hold on to its atmosphere. And so even though Mars has an atmosphere, we can see it's much thinner than the Earth's. Just look at the surface. You see craters indicating that it didn't have an atmosphere that could stop those impacts. Also, we see that it's the red planet. And atmospheric escape plays a role in Mars being red. That's because we think Mars used to have a wetter past. And when water had enough energy, it broke up into hydrogen and oxygen. And hydrogen being so light, it escaped into space. And the oxygen that was left oxidized or rusted the ground, making that familiar rusty red color that we see. So it's fine to look at pictures of Mars and say that atmospheric escape probably happened, but NASA has a probe that's currently at Mars called the MAVEN satellite, and its actual job is to study atmospheric escape. It's the Mars Atmosphere and Volatile Evolution spacecraft. And results from it have already shown pictures very similar to what you've seen here on Earth. We've long known that Mars was losing its atmosphere, but we have some stunning pictures. So here, for example, you can see in the red circle is the size of Mars, and in blue you can see the hydrogen escaping away from the planet. So it's reaching out more than 10 times the size of the planet, far enough away that it's no longer bound to the planet. It's escaping off into space. And this helps us confirm ideas like why Mars is red from that lost hydrogen. But hydrogen isn't the only gas that's lost. I mentioned helium on Earth and some oxygen and nitrogen. And from MAVEN, we can also look at the oxygen being lost from Mars. And you can see that because oxygen is heavier, it can't get as far as the hydrogen. But it's still escaping away from the planet. You don't see it all confined into that red circle. So the fact that we not only see atmospheric escape on our own planet, but we can study it elsewhere and send spacecraft, allows us to learn about the past of planets, but also about planets in general and Earth's future. So one way we actually can learn about the future is by planets so far away that we can't see. And I should just note, though, before I go on to that, I'm not going to show you photos like this of Pluto, which might be disappointing, but that's because we don't have them yet. But the New Horizons mission is currently studying atmospheric escape being lost from the planet. So stay tuned and look out for that. But the planets that I did want to talk about are known as transiting exoplanets. So any planet orbiting a star that's not our sun is called an exoplanet or extrasolar planet. And these planets that we call transiting have the special feature that if you look at that star in the middle, you'll see that actually it's blinking. And the reason that it's blinking is because there are planets that are going past it all the time. And it's that special orientation where the planets are blocking the light from the star that allows us to see that light blinking. And by surveying the stars in the night sky for this blinking motion, we are able to find planets. This is how we've now been able to detect over 5,000 planets in our own Milky Way. And we know there are many more out there, like I mentioned. So when we look at the light from these stars, what we see, like I said, is not the planet itself, but you actually see a dimming of the light that we can record in time. So the light drops as the planet decreases in front of the star, and that's that blinking that you saw before. So not only do we detect the planets, but we can look at this light in different wavelengths. So I mentioned looking at the Earth and Mars in ultraviolet light. If we look at transiting exoplanets with the Hubble Space Telescope, we find that in the ultraviolet, you see much bigger blinking, much less light from the star when the planet is passing in front. And we think this is because you have an extended atmosphere of hydrogen all around the planet that's making it look puffier and thus blocking more of the light that you see. So using this technique, we've actually been able to discover a few transiting exoplanets that are undergoing atmospheric escape. And these planets can be called hot Jupiters for some of the ones we found. And that's because they're gas planets like Jupiter, but they're so close to their star, about 100 times closer than Jupiter. And because there's all this lightweight gas that's ready to escape and all this heating from the star, you have completely catastrophic rates of atmospheric escape. So unlike our 400 pounds per minute of hydrogen being lost on Earth, for these planets, you're losing 1.3 billion pounds of hydrogen every minute. So you might think, well, does this make the planet cease to exist? And this is a question that people wondered when they looked at our solar system, because planets closer to the sun are rocky, and planets further away are bigger and more gaseous. Could you have started with something like Jupiter that was actually close to the sun and get rid of all of the gas in it? We now think that if you start with something like a hot Jupiter, you actually can't end up with Mercury or the Earth. But if you started with something smaller, it's possible that enough gas would have gotten away, that it would have significantly impacted it and left you with something very different than what you started with. So all of this sounds sort of general, and we might think about the solar system, but what does this have to do with us here on Earth? Well, in the far future, the sun is going to get brighter. And as that happens, the heating that we find from the sun is going to become very intense. In the same way that you see gas streaming off from a hot Jupiter, gas is going to stream off from the Earth. And so what we can look forward to, or at least prepare for, is the fact that in the far future, the Earth is going to look more like Mars. Our hydrogen from water that's broken down is going to escape into space more rapidly, and we're going to be left with this dry, reddish planet. So don't fear, it's not for a few billion years, so there's some time to prepare. But I wanted you to be aware of what's going on, not just in the future, but atmospheric escape is happening as we speak. So there's a lot of amazing science that you hear about happening in space and planets that are far away. And we are studying these planets to learn about these worlds, but as we learn about Mars or exoplanets, like hot Jupiters, we find things like atmospheric escape that tell us a lot more about our planet here on Earth. So consider that the next time you think that space is far away. Thank you.